Okay, so let's talk about rounding. Whenever we're rounding to a certain decimal place, it's important, I like to underline that decimal place. So if I was going to take this first value here, this 3.163, and we were going to round it to the nearest tenth, what I like to do is underline the tenths column because it's that number that we have to make a decision about. Are we going to keep it the same or are we going to bump it up? And the way we can tell is always by looking at the next number. So since we're rounding to the nearest tenth, I'm going to look at the hundredth. And if the hundredth is greater than 5, then we would round up. If it's less than 5, greater than or equal to 5, we would round up. If it's less than 5, we would round down. So if it's greater than or equal to 5, we round up. If it's less than 5, like if it was 3, 2, 1, 4, we would just keep it the same. And so here we're going to round up. And so our final answer when rounding to the nearest tenth would be 3.2 because the next value to the spot to the right of the tenths, the hundredths column, was greater than or equal to 5. What about to the nearest 10,000th? Let's look at this number here and round to the nearest 10,000th. So I'm going to go ahead and underline the 10,000ths column. So this is tenth, this is hundredth, this is thousandth, this is 10,000. So it's this number here, the 0, that we're going to decide if we need to round or not. And the way we're going to tell is by looking at the next value over, which is 9. So we are going to round up, and that would be 50.4321. That's how we would round to the nearest 10,000th on that one. On this last one, let's go ahead and round to the nearest 1. To the nearest 1. If I'm going to round to the nearest 1, I underline the ones column. I then look at the tenths column, the next one over, and decide if I'm going to round up or down. And this one also rounds up to 14. Okay, great. Let's go ahead and give you a few rounding problems. We'll give you 3 to round. What we'd like you to do is, just keep working here right in your notebook. And we're going to give you 3 problems to round. Here it is. Let's go with 3.075. We'd like you to round that to the nearest hundredth. Round to the nearest hundredth. There's a D in there. Round to the nearest hundredth. On this one, 4.1622. We'd like you to round to the nearest tenth. And the number 31444, we'd like you to round to the nearest thousandth. To the nearest thousandth. Okay, try those problems right here in your notebook. You can pause the video now and resume it when you're ready to check your answers. Okay, how'd you do with rounding? Rounding, let's go ahead and check these answers here and see if you were able to round these correctly. Here on this one, we're going to round to the nearest hundredth. So the hundredths column is right here. I'm going to look at this number to decide if I'm going to round up or down. Since it's a 5, we're going to round up. You should have written 3.08. How'd you do? Hopefully well. Let's look at this one. We're going to round to the nearest tenth column. So I'm going to underline the tenths. I'm going to look at the next number over. It's a 6, so we round. You bet, we round up. So it's going to be 4.2 is our answer. And for this one here, we're going to round to the nearest thousandths. So this is the tenths, hundredths. This is the thousandths column. I'm going to look at this number here. Are we going to keep it the same or round up? You bet, we keep it the same because it's less than 5. So the answer for that one would be 3.144. Percent notation. Before we start, I'd like to share this quote with you from President Mawson in the April 2011 conference about temple work. Let's see if you can identify the percent in this problem, since we're going to be talking about percents. He says, and I quote, "Today, most of us do not have to suffer great hardships in order to attend the temple. 85% of the membership of the church now lives within 200 miles of a temple. And for the great many of us, that distance is much shorter. If you have been to the temple for yourself, and if you live relatively close proximity to a temple, your sacrifice could be setting aside the time in your busy lives to visit the temple regularly. There is much to be done." Brothers and sisters, this is a great quote, and I love it very much. Not just because of the percent. Notice the percent he gave us is 85%. But also about the power that the temple and the blessings that comes from it. Many years ago, it took a long time to build temples. There were people that sacrificed lots of time, lots of money. It took 40 years to build the Salt Lake Temple, and it was a huge sacrifice. For us now in the church, most of us, 85%, live really close, within 200 miles. If you got a car, that's less than 3 hours. And so we need to take advantage of that. We need to sacrifice a little of ourselves, maybe by just going. I'd encourage you, especially if you're here on campus, to take advantage of being 2 blocks away from the temple and sacrifice a little. The blessings that can come from it are amazing, and I testify of that. Okay, now let's get to the math and talk about this 85%. What a percent is. So 85%, 85%. Percent. The word percent itself means of 100. Percent means of 100. And so 85%, any percent can actually be converted into a fraction simply by writing the number over 100. I could convert this to a fraction. 85 over 100. These two things mean the exact same thing. 85% and 85 over 100 means the exact same thing. In fact, this tells us that if we had 100 members of the church, 85 of them would live within 200 miles of a temple. This fraction can actually be simplified if we divide 5 out of the top and the bottom. If we did that, divided 5, we'd get 17 over 20. So we can convert any percent into a fraction simply by writing over 100, because that's what percent means. Take a look at another example. What if I had 7%? 7%, that can be converted. 7%, it would just be 7 over 100. Okay, great. So to convert a percent to a fraction, we just write that percent over 100. Let's have you all try some. I'm going to write up 3% that I'd like you to convert. The first one, 30%. The next one, 12%. And the last one, 125%. Take these fractions and convert them. Take these percents and convert them to fractions. That's your goal here. Pause the video and work on this in your video notebook. And when you're done, resume the video and we'll see how you did. Okay, let's get to it. 30%, you should have said 30 over 100, because percent means of 100. And we can simplify that by dividing the top and the bottom by 10. You're always going to want to simplify if possible. Great. 12%. That's 12 over 100. And we can simplify that by dividing the top and the bottom by 2. That gives me 6 over 50. Oh, it looks like it simplifies some more. Let's divide the top and the bottom again by 2. And I get 3 over 25. Great. The last one was 125%. To convert that to a fraction, we'd write 125 over 100. And we would get, if we divided the top and the bottom by 25, we'd get 5 over 4. So those are your 3 answers that you should have gotten in your video notebook. How'd you do? Converting percents to fractions, you just write it over 100 and simplify. Okay, great. The next thing we want to talk about is what if I have a percent and I want to convert to a decimal? Percent to a decimal. So if I want to do that, let's say I had, for example, let's go back to the 85% example. So President Hinckley's 85% example. If I want to convert that to a decimal, so it's a percent right now, and I want to convert to a decimal, you need to move the current decimal place over to the left 2 places. So if I was to think of this as 85%, well, the decimal place would be right there. And I could move it over 2 places, and that new spot would tell me what the decimal value is. And so in this situation, it's 0.85. So to convert a decimal, a percent to a decimal, just move the decimal place over 2 places. We could have also have seen this from the fraction that we did. These are all interrelated, all exactly the same. Remember, we said 85% was 85 hundredths. Well, that's just this. What about 27.2%? If I said write 27.2% as a decimal, what would we do? We would just move the decimal point over 2 places, which would be 0.272. That's how we convert percents to decimals. Okay, it's your turn. Let's have you guys try some. Here we go. We'd like you to convert some decimals here. The first decimal we'd like you, percent to decimal, 9.6. Convert that percent to a decimal. What about 129%? And last of all, 0.4%. Okay, your goal here is to convert these 3% to a decimal. Go ahead and pause the video and resume it when you're ready to see if you got these right. Convert from a percent to a decimal. Okay, great. How do we do? Hopefully we did all right. To convert from a percent to a decimal, you move the decimal place to the left 2 spots. So on this first one, I go to the left, and then I go to the left again. Now I'm going to have to put a 0 here to represent that spot. So really the correct answer for 9.6% as a decimal is 0.096. That's what we should have got on that first one, moving the decimal place to the left. Here, on 129%, the decimal place is right here, and I'm going to move it to the left 2 places. So I'm going to get 1.29. On this last one, 0.4%. I need to move the decimal place to the left 2 places. So in doing that, I'm going to have to write in some zeros to help hold the place, and our answer should be 0.004. Converting percents to decimals. Okay, so again, we want to be able to convert everything. So what if we started off with a decimal? What if I said, okay, here's a decimal. The decimal is 0.91. And I told you, okay, convert 0.91, this decimal, to a percent. Well, that would be the exact opposite of what we just did. We converted percents to decimals. When we went from a percent to a decimal, we moved the decimal place left 2 places. So if we want to go from a decimal to a percent, we'll do the exact opposite. We'll move it right 2 places. So 91 would just be 91%. 0.91 converts to 91%. If I gave you 0.037, again, we would move the decimal place 2 places, and the percent would be 3.7%. Okay, it's going to be your turn here. Let's give you some problems. I'll write them up right now. So we want you to convert 0.36 to a percent. We also want you to convert 0.031 to a percent, and also 3.26 to a percent. Go ahead and pause the video and work on these 3 problems. Convert these decimals to a percent. Okay, how'd we do? You should be moving the decimal place to the right 2 spots. So this first one, you'd get 36%. On the second one, you would get 3.1%. And on the last one, you would get 326%. That's converting decimals to percents. Hopefully we did all right. There's one last section we want to talk about. So what if we gave you a fraction and we said, okay, convert a fraction to a percent. So to do this, the first thing you're going to want to do is convert the fraction to a decimal. And then you can move the decimal place over 2 places. So, for example, if I gave you the fraction 3 over 8. Now, 3 over 8, that's kind of a complicated fraction. We may want to cheat here. Or not cheat, but use some help. You can use your calculator. We could do 3 divided by 8. And when I type that into the calculator, it gives me 0.375. Okay, so 0.375. Remember, for the tests, you get a calculator, so this is all right. I converted the fraction to a decimal. Now, to convert the decimal to a percent, we just move the decimal place over 2 spots. And so that would give us 37.5%. This is a situation where we found all 3 of the items we're talking about. We were given a fraction, we found the decimal, and then found the percent. Let's try one more. What about 20 over 25? So again, we could do this in the calculator. We could do 20 divided by 25. Push the enter button. I get 0.8. So as a decimal, it's 0.8. As a percent, we need to move the decimal place over 2 spots. And when we do that, 1, 2, we need to add a 0 here. We find out that it's 80%. Okay, so that's how we convert fractions to percents. Let's have you guys try 3 of those here. I'm going to write them up. Okay, so you have 17/50ths. Let's do 3/4. And last of all, let's do 7/4. So your goal here is to convert these 3 fractions to percents. Go ahead and pause the video, work on these in your notebook, and then when you're ready to check your answers, resume the video. Good luck! Okay, how'd it go? 17 over 50. What did you do? A couple ways you could have done this. I think I would have just typed in 17 divided by 50 in my calculator. That's probably the lazy way out, but it works really nice. I get 0.34, so that's 0.34. I really wanted to get a percent, so to go from a decimal to a percent, I move the decimal place over, and I get 34%. Sweet. 3/4 was another one. If you use your calculator, you get 0.75. When you move the decimal place over 2 spots, you get 75%. That's the one what you should have gotten there for that one. The last one was 7/4. When you type that into a calculator, you get 1.75. To convert to a decimal, we would then move the decimal place over 2 spots to the right, which gives us 175%. So there we have it. We've converted fractions to percents, decimals to percents, percents to decimals, and percents to fractions. Those are the steps to do it. We hope you had a good time here with this lesson. Remember, try to come up with some time to visit the temple. 85%. You're one of the lucky ones.
Hello and welcome to the section where we will be going over exponent rules. Yes, there are rules dealing with exponents. We're going to first review the first 3 E's of exponents. So when we had something like 2 to the 4th power, this was what we called in exponential notation. This guy right here was called the base, and that guy right there was called the exponent. And then together that's called exponential notation. So that's the first E, exponential notation. When you expand this out, what this really means is 2 times 2 times 2 times 2, and this happens 4 times over. A repetition of 4 timesing of timesing 2 by itself 4 times. So that's called expanded notation. So that's the second E, expanded notation. And then when you evaluate it, you get 16. So this is called expanded notation. Expanded. And then this guy right down here is when you evaluate it. And the nice thing is when you have numbers, you can evaluate them. You can stick them into the calculator. And as a reminder, this is what the calculator looked like when you did it. You did 2, and then the exponent was this caret looking thing over here. And your calculator may have something different. It may have an X to the Y button or something like that. 2 to the 4th power, and you'll see it comes up with 16 indeed. So that's exponential notation, expanded notation, and when you actually evaluate it out like that. Well, that's our third E.
Order of operations. To start, let's take a look at a scripture from Mosiah 4:27. This is King Benjamin talking. Let's see what he has to say. And see that all these things are done in wisdom and order. For it is not requisite that a man should run faster than he has strength. And again, it is expedient that he should be diligent, that thereby he might win the prize. Therefore, all things must be done in order. What a great principle! This idea of all things having to be done in order. In fact, it's mentioned twice. This idea of all things being done in order. This is a very important principle that we can apply to lots of parts of our lives, whether it be in the gospel, whether it be in our spiritual development, whether it be in our families, or even here at school while doing education. Things must be done in order. And this same idea can be applied to mathematics. And that's why we're going to be talking about what is called order of operations. There's an order in all things, including mathematics. And that's what we're going to be talking about. Let's take a look. So why must there be an order? Well, take a look at this example. Let's pretend we have one person who is really addicted to addition. Anytime he sees an addition problem, or she, they instantly want to do that first. So I look at this problem, 3 plus 2 times 6, and well, since I'm addicted to addition, the first thing I want to do is add. I would do 3 plus 2, which gets me 5, and 5 times 6, well, that's 30. Okay, so yeah, I'm addicted to addition. I did the problem. I got an answer. It looks great. Well, there could be another person, maybe on the other side of the road, another country, looks at the problem and says, "Whoa! I'm high on multiplication. I love multiplying. The first thing I always do is multiply." So I look at this problem and I say, "Wow, okay, I'm not going to do 3 plus 2. I don't like addition. I am a multiplier. So I'm going to do the 2 times 6 first." Well, that person will get 3 plus 12, because 2 times 6 is 12. He or she would then add 3 plus 12 and get 15. Well, now we look at these two answers and we say, whoa, no way. There's something going on here. Somebody is doing it wrong, and it's not technically wrong, it's just what your preference is. Well, mathematicians came together and said, there's a huge issue here. We have to apply what King Benjamin said. Mathematicians didn't really say King Benjamin, but they said there's got to be an order in all things, an order in mathematics. And we call that order the order of operations. And so we're going to talk about that right now. The most popular way to remember order of operations is by remembering a little, well, it's not a poem, but a little mnemonic device, which we usually say, "Please excuse my dear Aunt Sally," or PEM DOS. Okay, so the P stands for parentheses. The parentheses, we always work inside the parenthesis first. We then work on the E, which stands for exponents. We then do M and D, and I wrote it like this. You may not have seen it written like that before. I write it like that because it's important to remember that multiplying and dividing are in the same step, and you work from left to right. And then the last step is working with addition and subtraction. Those again are in the same step, and you work with left to right. Okay, so let's take this idea of PEMDAS, doing parentheses, exponents, then multiply, divide, and then addition, subtraction, to some problems. Let's do some example ones here. Let's take a look at this. 5 plus 3, close parentheses, squared, plus 2 times 5. So as we look at this problem, we want to make sure we apply the rules of order of operations. First thing we do is parentheses. So let's work inside the parentheses here. 5 plus 3, we get 8. So I'm going to write out that step, 8 squared plus 2 times 5. Next step then tells us to do exponents. We do have an exponent here, so we're going to do 8 squared. Well, that's 64 plus 2 times 5. What do we do next? We did parentheses. We did exponents. Now we're going to work on multiply and divide from left to right. So we're going to do the 2 times 5. That leaves us with 64 plus 10. And then the last step was add, subtract from left to right, and so our final answer is 74. So that's how we use order of operations to solve problems. Let's take a look at another one here. What if I had 5 plus 3 squared minus 8 divided by 4. So again, we're going to do the same thing. We want to apply our order of operations. So first thing we're going to do is parentheses. There are no parentheses in here, so we can move on to the next step, which is exponents. We do have an exponent, 3 squared. So I get 5 plus 9 minus 8 divided by 4. I then am going to apply multiply divide. We do have a division, so we're going to do 8 divided by 4. So I get 5 plus 9 minus 2. Next thing we do is add and subtract from left to right. So 5 plus 9 we do first, which is 14. And then we subtract the 2, which is 12. So that was the answer to that one. So that's how we apply order of operations. Please excuse my dear Aunt Sally to math problems so that we all do it the same way. And we all get the same outcome. Okay, so now it's your turn. Let's have you try these problems right here. Here we have 21 minus 3 times 6 plus 7. That's your first problem that we'd like you to do in your notebook. Second problem is 100 plus 2 cubed plus 8 divided by 2. So take out your video notebooks. Go ahead and pause the video now and work on those. You can resume the video to check your answers. We'll see you when you're done. Okay, great. Please excuse my dear Aunt Sally. I'm working with this first problem here. First thing, parentheses. There are none. Next thing, exponents. There are none. So now we're going to go to multiply and divide. So 3 times 6, that will work. 3 times 6 is 18 plus 7. Now we do addition and subtraction from left to right. So the first thing we're going to do is this, 21 minus 18. That's 3. Again, left to right. So I started with the subtraction first, and then the addition, giving me 10. How'd you do? Hopefully you followed those steps and got it right. If not, we'll give you some more practice here. Here we go. Let's look at the next one here. Again, I'm going to parentheses. That's the first thing we do. There are none. Exponents. Ooh, we do have 2 cubed. So 2 cubed means 2 times 2 times 2. So that's 8 plus 8 divided by 2. I'm writing out all the steps. So we did exponents. Now we want to do multiply divide. We do have a multiply divide here. So I have 100 plus 8 divided by 2 is 4. And now we're going to add from left to right. We get 108 plus 4. And that's our last step there to get 112. How do we do? Let's try a few more. See, make sure you're all on the same track here. Okay, here are 2 more problems for you to try in your video notebook. The first one is 4 plus parenthesis 2, parenthesis 3. This means, whenever you see this, this means multiply, minus 2 squared. And here the other problem is 7 plus parenthesis 12 minus 5 times 2, close parenthesis, squared. Go ahead and pause the video and work on these 2 problems. And resume the video when you're ready to check your answers. Okay, great. So first thing we should have done here is definitely the exponents. So I've got 4 plus 2, 3. Again, when you see 2 parentheses written together, that just means multiply. That's an implied multiplication. We're then going to do the multiplication, which is 4 plus 6 minus 4. We then add and subtract from left to right. 4 plus 6 is 10. 10 minus 4 is 6. Let's take a look at this one. Here we've got parentheses, so we're going to work inside the parentheses first. As we work inside the parentheses, are we going to do the subtraction first or the multiplication first? Oh, I hope you said multiplication. That would be right. So I have 7 plus parenthesis 12 minus 10, close parenthesis, squared. Now we do the subtraction. 12 minus 10 is 2, so I'm left with 7 plus 2 squared. Now we do exponents, which is 7 plus 4, and our final answer is 11. Okay, great. There's one last thing we want to show you, and then we'll be done with our point 5. The last type of problem that we want to discuss are problems that are written as fractions. For example, if I was to give you this problem here, 8 plus 2 times 3 all over 4 plus 3 minus 1. So in a problem like this, you want to work strictly with the top first. So we would pretend like the bottom of the fraction's not even there. We're just going to work with the top. And so I would do, first I would do the multiplication. So I would have 8 plus 6, and then I would add that together to get 14. Okay, great. Once you have strictly the top, all the top done, now you can work with the bottom. So we would do, right here, we would work with the inside the parentheses first. 3 minus 1 is 2. So we have 4 plus 2. 4 plus 2 is 6. And we're left with 14 sixths. Then, once you have worked just with the top and just with the bottom, then you can do the division. 14 divided by 6 is 2 and 2 sixths. You can do that in your calculator. That actually simplifies to 2 and 1/3. So again, just work with the top, then just work with the bottom, and then when you've got it all worked out, you can do work with that final fraction and do the division. Let's give you two problems to work on like those. Okay, so here are the last two problems we'd like you to do in your video notebook. The first one is 13 times the quantity 10 minus 6, close parenthesis, plus 4 times 9. That's all on top. And then we're putting that all over 5 squared minus 3 squared. This other problem is here also in blue. It is 5 minus 1 plus 3 on top, all over 15 minus the quantity 3 minus 1, close parenthesis, or close quantity cubed. Go ahead and pause the video. Make sure you work with just the top, then just the bottom, and then simplify the answer once you're done. When you're ready to see if you got them right, you can resume the play button. Okay, so how'd you do? Hopefully pretty well. I would go ahead on this problem and work with parentheses first. That's the rule. So I'd have 13. Left inside the parenthesis would be 10 minus 6, which was 4, plus 4 times 9. I'm just working strictly with the top right now. I now want to do multiplication from left to right. 13 times 4 is 52, plus, this is the other multiplication, 4 times 9 is 36, and 52 plus 36 is 88. So that's what we had on top. Don't forget. In fact, I'm going to write a little note here because I don't have much room. I'm going to remember that 88's on the top. Now let's look at the bottom. 5 squared, we're going to do exponents first, so I get 25 minus 3 squared is 9. 25 minus 9 is 16. And that's what we got for the bottom. So what we're left with then is 88 over 16. You could plug that into your graphing, into your regular calculators if you'd like. And when you do that, it will automatically simplify these to 11 over 2. And that's the final answer for that one. Okay, great. The last problem. Let's work with just the top. We're going to do add, subtract from left to right. So 5 minus 1 is 4, plus 3 is 7. Down here, we're going to do parentheses first. 3 minus 1 is 2, so I have 15 minus 2 cubed. 2 cubed is 2 times 2 times 2. That's 8. Again, you could use your calculator if you needed to. 15 minus 8 is 7. And so the bottom, we're just left with 7. And on top we had 7. So 7 divided by 7, the answer to that one is 1. So our two answers were 11 halves and 1.